The orbital insertion parameters are holding steady across all models. Acknowledged. Uploading the final sequence now.
Using portable laser scanners, engineers verify the dimensional accuracy against the CAD blueprint projected directly onto the metal.
Guided by synchronized robotic arms, the carbon fiber panel descends with incredible precision. Engineers meticulously inspect every meter, cross-referencing the laser scan data now. 0 deviation detected. Character A. Excellent. Final approval confirmed. The integration process begins under the strictest conditions. Technicians use ion. The satellite's solar arrays are assembled with extreme precision. Thousands of photovoltaic cells.
Before launch, every deployment mechanism is tested repeatedly. Engineers must be certain the solar arrays will unfold perfectly once the satellite reaches orbit.
Agents. With assembly complete, engineers begin comprehensive electrical testing to verify that every onboard system communicates.
Reliable communication is essential. Every antenna must transmit and receive signals with absolute precision.
Even the smallest moving mechanism must perform flawlessly. A single failed deployment in orbit could prevent an entire satellite mission from succeeding. Extreme temperatures in space demand exceptional thermal protection. Every layer of insulation helps keep sensitive electronics operating within their safe limits. Before reaching space, every satellite must survive the intense vibration produced during rocket launch. These thousands of sensors record every response during testing, allowing engineers to verify that the satellite remains structurally sound under launch conditions. Rocket launches generate extraordinary acoustic energy. This chamber recreates those conditions to ensure every component remains secure during ascent. Inside this chamber, engineers recreate the vacuum and extreme temperatures of space, proving the satellite is ready for the environment it will soon encounter.
After surviving the harshest environmental tests, engineers carefully verify every subsystem once more before.
Only after every engineering team grants approval can the satellite officially earn its flight-ready certification, marking the completion of years of development and testing. With manufacturing complete, the satellite begins one of its most carefully protected journeys, from the factory to the launch site where its mission will finally begin. At the launch center, every step is performed with extraordinary care to protect the spacecraft before its final integration with the launch vehicle. The final software checks and system verifications ensure the satellite is fully prepared before becoming part of the launch vehicle that will carry it into space. This precise connection links the satellite to the launch vehicle, creating the final spacecraft configuration that will soon. The payload fairing shields the satellite from intense aerodynamic forces during launch, protecting the spacecraft until it reaches the vacuum of space.
After years of design, manufacturing, and testing, the mission reaches its final stage as the launch vehicle takes it out.
With every system connected and verified, the launch team begins the final countdown. Carefully
inside mission control, every engineering team confirms its system is ready. Only after every station reports go can the countdown continue.
In the final seconds, control transfers from the ground to the rocket's onboard computers, preparing every system for the moment of liftoff. After years of preparation, the engines reach full power. Once every parameter is confirmed, the rocket is finally cleared to leave Earth.
The launch vehicle rapidly gains altitude, carrying the satellite beyond Earth's atmosphere while engineers continuously monitor every stage of the.
As the atmosphere becomes thinner, the spacecraft approaches the environment where its protective fairing is no longer required. With the atmosphere left behind, the protective fairing separates, revealing the satellite as it continues its journey toward orbit.
With the target orbit achieved, the mission enters its final phase as engineers prepare for the satellite's deployment into space. At precisely the right moment.
Immediately after deployment, the satellite stabilizes its orientation and prepares to activate the systems that will sustain its mission in orbit. With its solar arrays fully deployed, the spacecraft begins generating the electrical power required to support every onboard system throughout its mission. The first successful communication confirms that the satellite is healthy, fully powered, and ready to begin the mission it was built to perform. Years of engineering culminate in this moment, as the satellite begins collecting valuable information and transmitting its first operational data back to Earth.
Continuous communication allows engineers to monitor the spacecraft's health while receiving the scientific and operational data gathered during every orbit.
Earth. Orbit after orbit, the satellite quietly performs its mission, collecting information that supports science.
From a simple engineering concept to a fully operational spacecraft, every stage of manufacturing made this remarkable journey possible.
What began as an idea inside an engineering laboratory has become a living spacecraft in orbit.